Hey guys, welcome back to our video on demand series. We're going to be dealing with the next bullet point in our blueprint, which is our MTU size. What is our MTU? How do we adjust it? What are some of the things that we need to be aware of? Well, first of all, when we say MTU, what we are saying is our maximum transmission unit. That's what MTU actually stands for. What we are saying when we say our maximum transmission unit, our MTU size, is what we are saying is that once we have a frame, once our packet is actually built and we have a frame of all of these different pieces put together, so we have our IP header, our TCP header, we have all these headers, and we have the actual data that we're trying to send. Once this frame is put together, how big is that frame allowed to be as we send it across our network? That is what the MTU size actually is. It's not just the data. So it's not just how much data we are allowed to send, because the frame consists of more than just the data, okay? Let's take a look at a typical Ethernet frame. Let's just take a look at what I mean by just having more than just the data. So let's say the first thing, or the first field that we are going to have, is our DLC, our data link control field. This field is going to be 14 bytes generally, okay? We're going to contain our source and destination MAC address. So inside of the DLC, we will have our source and destination layer 2 information. Now, each one of these pieces are going to be 6 bytes each. Well, yeah, okay, JP, but that's only 12 bytes. What happens to the other two? Because you said it was 14 bytes. Yeah, the remaining 2 bytes are going to be what we call the ether type. So I'm going to write that up here, and I will try my best not to have chicken scratch. One of the reasons why I like to do slides is because I have chicken scratch, and I've noticed a lot of us instructors have some pretty wicked chicken scratches. So I like to just pre-type it and use spell check so that I don't have to worry. So we're going to have this 14-byte field that is going to have our source and destination MAC address, and then our type, our ether type. That's going to, so again, two sets of 6 and then 1, 2. It's going to equal out 6 plus 2 is going to be 14, right? Now, the next field we're going to have is going to be the IP header. Now, the IP header is going to be 20 bytes, and typically what we're going to find is our source and destination IP address. So where am I sending this to, and who am I sending it from? So we're going to have this 20-byte field that's going to contain that information for us. Now we're going to get to the TCP header. Now the TCP header can be a minimum of 20 bytes, so this I'm going to write minimum, or it can be a maximum of 60 bytes. Now in my case, I'm going to write it over here. In my case, in the packet capture that I'm going to bring up, and in the calculation that we did here on this particular slide, we had a maximum amount of data that we could send of 1,438 bytes is what is the maximum amount of data that we are allowed to send. And the reason is because we have this DLC header, we have IP, we have TCP. By the way, inside of the TCP header is going to be where we find our source and destination ports. So in my case, I configured my network for BGP, and that's what I was using to generate some IP traffic and to just show the source and destination. So on one side, I have a higher random TCP port. On the other side, I have a lower TCP port of BGP 179. Those of you that got it, good job. So once we add these fields together, let me skip data for a second. Once we add these fields together, we can come over here to this remaining field of the SCS. This stands for our frame check sequence, okay? Or essentially a checksum, all right? So this frame check sequence is going to be 4 bytes. So let's just go grab the calculator for a second. And you can see that I have it already added up. Let me actually bring it further into the screen. So in my case, right, we had 14 bytes for our DLC. Then we had 20 bytes for IP. We had 24 bytes for TCP, plus 4 bytes for our FCS. So we had 62 bytes without even adding any data. So before we even put data into the packet, we had 62 bytes. Now, how can I tell if my maximum transmission unit, if my max MTU size, which by the way is a default of 1500, so if my maximum MTU was set to 1500, how much data can I actually have in this packet? Well, let's clear this, and we'll say 1500 minus 62 comes out to 1438. So we can have a data field in our packet, and that's exactly what we see of 1438. Now this payload, this data field, is actually going to be what we're trying to send to our particular destination. So these are going to be the different fields that we're concerned with in an Ethernet Type 2 frame. Now, we also have another frame that we're going to be dealing with on our lab, and that's going to be our GRE frame. Now, a GRE frame works a little bit differently because we encapsulate everything inside of GRE. And we'll get to in later videos what GRE is actually doing and how it works and all that good stuff. But for now, we're going to encapsulate everything inside of this GRE tunnel, right? And we're generally not going to, especially if we're running this on the public side, right? So if I'm peering with a neighbor because I don't have layer 3 VPN running, and I want to have a quote unquote direct connection, I might configure a GRE tunnel, and I'm not going to generally leave that open to the outside world, so I'm going to encrypt it. So what's going to happen is on our packet, and again, we're going to take the default of 1500. So on our frame, we are going to have 4 bytes that take up our IPsec. So we're going to have a 4-byte IPsec header. We're going to follow that up by a 24-byte GRE header, which gives us 28 bytes total. Well, that leaves us, if we do the math, that leaves us with a maximum payload of 1472. Now, if we removed IPsec, and let's say we were using this on our internal network, and we just had 2 directly connected, or two quote-unquote directly connected devices, right? And they were on our internal network, so we weren't worried about encrypting it. We would have a maximum data field of 1476 because essentially we're going to get these 4 bytes back, and they're going to go into our data field. So remember that this data field is essentially what is left over, okay? What's left over after we've added all of these different fields into our frame. So now we get into how do we know that we have the same MTU size across the board? Because let me mention something. When we send a packet, so when I send you a packet, and let's say that my MTU size is 1500, and I send you this packet of 1500, you might not be able to receive it. And so that's where we get into fragmentation. You're going to tell me that you cannot, unfortunately, receive this packet that is huge by your standards, and I'm going to have to break it up. That's what fragmenting is. So fragmenting is when we take this 1500 byte packet and we essentially draw a line through, again, essentially what your maximum is. So we're going to take this packet, we're going to cut it in half, or we're going to cut it, maybe 3/4 on one side, 1/4 on the other. You have to do the math, but we're going to say, all right, I'm going to take this 1500 byte packet and I'm going to fragment it. I'm going to break it up, and I'm going to send you this one big frame in 2 different chunks. Well, the problem is when you receive these 2 different chunks, you have to put these 2 chunks back together in the right order to essentially make up that frame that we originally sent you. Now, you can do that, and that does happen. But the problem is, what happens if we start to have a slow link or packet loss, or we start to have a problem where maybe for whatever reason, bandwidth, congestion, whatever, those frames that are fragmenting are starting to get delivered in the wrong order, or they're starting to, or your device is not able to put those frames back in the order that they need to be in. Essentially what now happens is now we have this packet loss problem, and I'm not saying that's why we have packet loss, but essentially we're going to start dropping these frames. We're going to start dropping these fragmented frames, and you're not going to be able to put this stuff back together. So let's think of voice for a minute. Your voice traffic needs to essentially get to your destination in real time, right? Well, if we have fragmentation, it's not going to deliver, it's not going to get there in real time because I'm going to say it, and then your device is going to receive it, but it's going to receive it in 2 different frames. It's going to receive it in 2 different chunks of the same frame and have to put these 2 pieces of the frame back together. So that's what we want to avoid. We want to avoid fragmentation. Now, the industry delivered to us what we call path MTU discovery that essentially allows us to find what the lowest MTU is going to be, and is going to allow us to send a packet within those constraints of that particular interface or device that supports a lower MTU. That way we can send one continual frame. So if I find out that you only support a 1300 byte frame, I can send you a frame of 1300 bytes, and then maybe I send you another frame of 300 bytes. Or 200 bytes, or whatever the math calculates out to be. Essentially, you'll accept both frames, and you're not going to have one frame that's cut in half and that you have to put back together and worry about, okay, which piece of this came first, I have to reconstruct this frame. You're going to receive two different frames, which is going to make it a lot better off. The problem with Path MTU discovery is that we rely on ICMP traffic. Oops, sorry about that. Is that we rely on ICMP traffic, and most of us are blocking ICMP traffic in our infrastructure, in our network. So we're almost limiting the way that we deal with Path MTU discovery. So if we want to use this feature, I mean, it's built in. We just have to allow ICMP traffic so that we can actually detect or find out what is going to be the minimum MTU size that I need to send, what is going to be the right MTU size that I need to send throughout my infrastructure, so that I can deliver the packet successfully from one end to the other. Now, when we deal with MTU, let's jump into a packet capture. When we deal with MTU, we have to understand how to read it. We have to understand what it actually looks like. So let's actually jump into a packet capture, and I'm gonna walk through this connection that we had in BGP. So we'll start from the bottom up. This is going from router 1 to router 2. And we're going to have our TCP header. So here's our TCP header. We have our source port of 53.123. We have our destination port of 179 because, again, we're using BGP. Notice down here it told me that my the header size based on the TCP options that were set, again, it can be anywhere from 20 as a minimum to 60 as a maximum. And that's going to be based on the amount of TCP options that we're going to have in the packet. So we're going to have, in this case, in my case, a TCP header size of 24. Now, if you scroll down just a little bit, you're going to see that the maximum segment size that I was allowed to send in this case was 1490, because on the device that I was dealing with, the MTU was set higher, and so we have now a maximum segment size of 1490. That's okay, that's what I expected. But I'm showing you where these fields are in the packet capture so that you know what to look for. And then we'll get to how do you change them. The next thing that we're going to have after our TCP header, again, is our IP header. So we're going to have a header length of 20, so we have 20 bytes, that's how big our field is, and we're going to have a source and a destination port. Now, source and destination IP address. Now notice what we see here in our packet. We have what's called a don't fragment. So remember what I was saying to you before, how we may have an instance where we receive a packet that is bigger than what we're allowed to receive. What do we do with the packet? We fragment it. What happens in the instance that my packet here, as you see, has the don't fragment bit set? Well, in this case, we're going to drop this packet because our packet has been told you are not allowed to fragment. You're not allowed to be broken up into different pieces. You have to arrive as this one whole frame. And so since we have to fragment it, we can't fragment it, but we have to fragment it. We don't know what to do. We're going to drop the packet and we're going ahead and retransmit it. Well, if we don't fix this issue in our infrastructure, we're going to continue to drop these packets because we're sending a larger MTU than we're allowed to receive, and our application has set the don't fragment bit inside of the packet. This is one of the reasons why in our infrastructure, as good engineers, we should be maybe raising our MTU size to a size that's more suitable for what we expect in our infrastructure. Lastly, we're going to have our Ethernet frame. And again, this is where we're going to find our source and our destination layer 2 addresses. So here's my destination MAC, here's my source MAC. It gives us in kind of the summary of the packet. And then here's my type, which in this case is going to be IP. So these are the different fields that I'm going to find within my packet. And if I'm looking at a packet capture, this is where I'm going to look for them, okay? And again, these are going to be the different packet values that I'm going to expect, okay? These two are kind of dynamic because the TCP, based on the options, are going to either shrink or they're going to increment or they're going to decrement. And the data field, the amount of data that I'm allowed to send is going to be based on what's left over in my header, in my packet. So how do you change these? Let me go to my CLI. How do you change these? So let me get in my switch and say show system MTU. Oops. So you'll see here by default, my MTU size on my switch is going to be 1500. So here's my default system MTU, here's my jumbo MTU, and here's my routing MTU. So what are the differences between these three? The system MTU is going to be anything that is a 10100 interface. So any 10100 interface, whether it be 10 meg or 100 meg or whatever it's talking at, whatever we've set it to, any interface that is a 10100, we are going to be dealing with our system MTU size. Okay. Now, any interface that is 1 gig or above is going to be our jumbo size. Okay. So those of you guys that may be running an iSCSI SAN and maybe you're dealing with 1 gig connections. I mean, it's kind of slow these days, but what if you are? You're going to set your jumbo frame size to its maximum, which in this case is going to be 9,000. Now, so our system MTU 10100, our jumbo MTU is going to be our 1 gig and above interfaces. Lastly, we're going to have our routing MTU. Now, our routing MTU is kind of, I look at it as this redheaded stepchild, because the routing MTU is going to be what our layer 3 interfaces are going to do. If I say no switch port on an interface, obviously a routed interface or an SVI is going to be using my routed MTU. The thing is that the routing MTU is based off of the system MTU. Let me show you how to change these, and then I'll show you what I mean. So we'll say system MTU. Notice when I hit the question mark, I have my 3 options, right? I have my system MTU here. This is my basic system MTU. Then I have jumbo and routing. Now, if I just again hit the question mark, I can see that I can set my system MTU, and my maximum can be 1998. So let's go ahead and set it. Let's max out our device here. My switch is going to yell at me. It's going to bark and say it's not going to take effect until your next reload, and that's okay. We'll say system MTU jumbo, and my jumbo packets for my 1 gig and above interfaces, the maximum I can have is 9,000. So let's go ahead and set that as well. The system takes a minute and says, hey, not going to take effect until you reload, and that's fine. Now, system MTU, and I'm going to say routing this time. Notice my routing MTU, the minimum can be 1500 and the maximum can be 1500 because it's based off of the system MTU. And even though we've set the system MTU to 1998, which in this version of code is the maximum that we can have, the problem is it hasn't taken effect yet because we haven't rebooted. So we can't increase the routing MTU size just yet. So what we're going to do is I'm going to write this config, I'm going to reload the switch, I'll pause the video, and then I'll come back once it reloads and we'll go ahead and change the routing MTU. So let's go ahead and do that really quick. So we'll say do write, and we will say reload, and we will confirm it. Switch is reloaded. Let me go ahead and get into it, and we'll say show system MTU. Notice how now my system MTU size is 1998, my jumbo size is 9,000, and yet my routing MTU size is still 1500. And I promised you guys that we would come in and fix it. So now we'll say system MTU routing. Notice when I hit the question mark now, my minimum is 1500. That's the smallest I can go. But notice now that my maximum can be 1998, which is the max system MTU that I have. So I'll go ahead and say 1998. The cool thing here is that it no longer requires me to reboot my device because I've already rebooted. My system MTU is already to its maximum size, and so I don't need to reboot again. I'm simply allowing these particular, I'm simply allowing my routed interfaces, my layer 3 interfaces, to simply use the same MTU size as my system interfaces, essentially my 10100 interfaces. So these are going to be, sorry about that, show system MTU. So this is going to be how we may be asked to set our different MTU sizes and how we might need to implement these different things. Now on routers, we may need to do this on the interface with the command IPMTU, and I don't have a router handy at the moment, but essentially you're going to go into that interface It's not going to accept the command, but I want to show it to you anyway. You'll say IP MTU, and then you'll type the size that you need to set for that particular interface. So these are the ways that we're going to have to manipulate our MTU sizes. Generally speaking, again, they're going to be calculated for us. We're going to be able to send, within the lab. I mean, in the real lab, we're not going to actually pass all that much data, so we're not really going to be concerned with setting our MTU size. However, in the lab, you do what they tell you, and you're going to need to know the different ways that you have to come in and maybe manipulate the MTU size of your particular device. Again, this is how you do it. Do what you're told in the lab, even if it doesn't make sense. But in the real world, you may also want to increase your MTU size, because you're going to again expand that data field that you're allowed to send in the packet. So I hope you enjoyed this video. Keep on studying, and I will see you in the next one.